So this is a function because it passes the vertical line test. The second question asks, when should Mr. White have sold the company? Year 8, because it was worth 32,000. But in year 16, it was also worth 32,000. So why not sell it in year 16? We had to wait 8 years to get the same amount of money, right? And the value did drop, but it came back up. So technically nothing was lost, but you don't want to wait 8 years for the same amount of money. Okay, third question. When would have been the worst time to sell the company? Year 12. What sort of patterns do you see in the graph? Okay, sure, certainly some ups and downs. Can you be more specific? Right, this one looks like it's linear because it's a straight line. This one looks like a parabola, so this might be quadratic. What about the last one? It looks exponential. So the next question says, do you see those same patterns in the numbers that are listed in the chart? So the function changes at 8 and at 16. So from 0 to 8, do we see a linear pattern? How do we know if something's linear? By looking at a chart. Common difference, common first difference. So if you look, all of these are plus 3. So it is in fact linear. And then from 8 to 16, it looks like a parabola, but looks are never enough when you're dealing with polynomials, except for linear. How do we test to see if it's a quadratic? Second difference. So if we calculate the first differences, we have negative 16, no, 14, negative 10, negative 6, negative 2, positive 2, positive 6, positive 10, and positive 18. So my second differences would be 4, 4, 4, and so on. Is it a quadratic? Yes, and because the second differences are 4, I know something else about the quadratic. What's the leading coefficient? Not 4, 2, half of the second difference. So whatever equation this is, it's going to be 2x squared. And finding the rest of it's kind of messy. All right, and then from 16 on, does that have an exponential pattern? So exponential equations have a common ratio. What is the common ratio? Well, and we always express ratios in terms of multiplication. So it is divided by 2, but in terms of multiplication, it would be times by 1/2. We always want the multiplication version, not the division version. All right, so the next question asks, find the functions of each of the 3 equations you see in the graph. Once upon a time, we did these by hand. And then we learned the faster way using our calculator. So pull out your calculator. We no longer have to calculate these by hand. But I have 8 points in that linear equation. How many of those points do I actually need to write the equation? I need 3 to figure out that it's linear. But if I know it's linear, I only need 2 points to find the equation. So here, I just need 2 points. How many points do you need to determine if it's a quadratic? Well, you need 2 second differences. So if you look at the chart, 2 second differences are created using 4 numbers. So I need 4 to figure out if it's a quadratic. But if I know it's a quadratic, how many do I need to write the equation? Just 3 points. What about exponential? 2 is enough. 3 to figure out what it is, but 2 to write it. So, everybody go into Stat, Edit, and then you can pick any 2 points in that linear section, any 2 points from 0 to 8, and it will work. So I'll pick 0 and 1. Corresponding y values are going to be 8 and 11. Then you push Stat, And then go over to calc, and we want linear regression, which is number 4. Yeah, no idea. I don't have any idea how to use that. You probably want to go into table or list. Nope, not that. Try list. Statistics. Go into statistics. Yeah. So clear out those lists. And after that, I don't know what to do. In the past, we put y1 either here or if you have the other version of the calculator down where it says store regression equation. We don't really want to graph these. You can put y1 if you want, but we don't need it. We already have the graph. All we're looking for is the equation. So I'm just going to push enter. And I get the function 3x plus 8. That is my linear equation. Just put in any two of these. Doesn't matter which ones. So I now want to find the quadratic equation. I need 3 points. So edit, and you pick any 3 points, and you can even put them in out of order. So I'll put in 8, 9, and 10, and the corresponding y values for me is 32, 18, and 8. Okay, then I go into stat calc, and I'm going to do number 5, quadratic regression. And this should be 2x squared, and then who knows what comes after that. So, function here, 2x squared minus 48x plus 288. So, how come this 288 is such a big number? If I started with $32 on that quadratic, why does it have a plus 288? That is not the first value in the quadratic, it's where the quadratic hits the y-axis. So if I were to follow that parabola back to 0, it would be up at 288. And the exponential number is even going to be bigger. If I follow this exponential number up backwards, it's going to hit up in the millions range. So to find the exponential equation, go into stat, edit, clear out your lists. Yeah, yours will be the same. You'll just have to hit the little more arrow, and yours will be the EXP button. So you pick any 2 points in the exponential range. I'll pick x equals 16 and x equals 17. And the corresponding values are 32 and 16. And then stat, go over to calc, and the exponential is near the bottom. I think it's number 0. So if you go up from the bottom, right there, exponential regression. And I get 2 million times 0.5 to the x, which is what we expected. We knew that it was shrinking by 1/2. So 2097152 times 0.5 to the x. Okay? Now, what we're learning today is how to blend in all of these functions into one. So whenever you have a function that's made up of multiple pieces, this has a linear piece, a quadratic piece, and an exponential piece, we call it a piecewise function. And in a piecewise function, you follow some pattern, and then you switch to a different pattern, and then you switch to a different pattern. So what we're going to do is turn all of these functions into one. So on the very last problem, you're going to write f of x, that's the name of the function, and then we have this funny set notation parenthesis. And this says that f of x is actually made up of 3 equations. And you list the equations in order of their x values. So 3x plus 8 is the first one. 2x squared minus 48x plus 288 is the second one. And 2,097,152 times 0.5 to the x. I'm going to move these over. Okay. Once you have the equations written down, you need to qualify each equation. You need to state where this equation actually exists, because the first one's linear and the line goes forever in both directions. But the function only exists on a defined x interval, a domain. So what is the domain of the linear function? Which values of x does the linear function exist? From 0 to 8. So the way I prefer to do this is to use interval notation. So I'm going to say this function when x equals every number from 0 to 8. Is 0 part of the function? Yes. So we use bracket. Is 8 part of the function? Well, that's kind of a tough question. Does 8 belong to the linear or does it belong to the quadratic? Both, really, but mathematically we have to pick. You can't double define your x value. That's against the rules. So we have to decide, is 8 part of the linear or part of the quadratic? And in this case, it doesn't matter because it's the same number. But what if the graph came up here and had an open circle, and then it started down here with a closed circle? Would 8 be part of the linear or part of the quadratic? It would be part of the quadratic because this is closed and that is open. But in the function we're looking at, it doesn't matter because they both end at the same point. So you just have to choose. You have to choose either linear or quadratic, and it doesn't matter. So do you want to include this one or not? Both said no. So we'll put a bracket. Now, for those of you going on to calculus, which I hope is many of you, we always use interval notation in calculus. But for some reason, in this class, people like to use the old-fashioned inequality, which looks like this. 0 less than x less than 8. So it's always small number less than x less than big number. Are either of those an equal to? The 0 is an equal to, so that's what it would look like. So in the assignment today, you're going to see inequality notation, and I prefer interval notation. Use whichever one you like. Okay, so when is the quadratic equation valid? When x equals, when does it start? At 8. When does it end? At 16. Do we include 8? We have to. How come? We didn't include it on the previous one. And I'm going to go ahead and include 16. But we have the option. You could either put it with the quadratic or put it with the exponential because they share an endpoint. Okay? In inequality notation, it would be 8 less than x less than 16. Do either of those get equals? Both of them do. So it would look like that. All right? For the exponential, when is the exponential equation valid? From 16 until... Do we have any reason to believe it stops at 24? No. So, infinity. Do we include 16? No, because we included it on the problem above. Do we include infinity? No. So that's the function. Inside the function, you list all of the equations in domain order. And once you do that, you list each domain for all of those individual functions. Okay, so we turn this over. Here is a piecewise function. Let's just do this. It's faster. So here we have a linear function, a quadratic function, and an x to the third function. Okay? The first question asks, what is f of negative 4? Well, if we look at the domains, which one of those domains includes negative 4? So is negative 4 between 2 and 4? No. Is it between negative 2 and 2? No. Is it between negative 5 and negative 2? Yes. So to find the value at negative 4, we plug it into the top equation. So what is negative 4 minus 5? Negative 1. So the opposite of negative 4 minus 5, that's just 4 minus 5, which is negative 1. Well, I could have used the graph. If you go to x equals negative 4, what's the corresponding y value? So negative 4 comma negative 1, the answer is negative 1. All right? The next question is f of negative 2. Which function does negative 2 belong to? Well, it looks like the first or the second, but you need to check the domains. Which one is negative 2 a part of? Has to be the top, because this says x is less than or equal to negative 2, and this one says x is bigger than negative 2. So we need to plug it in to this one, or you could go to the graph at negative 2 and figure out the answer is negative 3. Does that make sense? So you can't just randomly plug the number into the equation because you have 3 equations. So you need to use the domain to figure out which equation to plug the number in. So the next one says f of 2. So if I look at the domains, does 2 lie in that domain? No. Does 2 lie in that domain? Almost, but not quite. Does it lie in that domain? Yes, so we plug in 2. 2 minus 3 is negative 1. What's negative 1 to the third? Negative 1 plus 2 is 1. Or you could have gone to the graph. Here is my x equals 2. Is it the top number or the bottom number? The top number, because the bottom number is an open circle. So the answer is 1. For the last one, f of 0. Which function includes 0? The middle one. 0 is in this domain here. So I plug in 0. So negative 0 squared plus 1 equals 1. And you can see that on the graph. That's the point 0, comma 1. So f of 0 equals 1. Okay, so part of your homework tonight, I want you to find the domain, range, maximum, minimum, x-intercepts, y-intercepts. The only tricky part is the increasing. It's increasing from here to here. That's obvious. So from negative 2 to 0. Where else is it increasing? From 2 until... Good. What happens here? It's flat. And if it's flat, it's not going up or down. So it's increasing, 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 flat, increasing, increasing, increasing. So you can either turn that into 2 intervals. So bracket 2, comma 3, parenthesis, and 3, 4, bracket. That's one way to do it. There's an easier way. Anybody know an easier way? From 2 to 4, both of those are brackets, and throw out 3. So it's increasing from every number 2 to 4, including 2 and including 4, but we'll throw out 3. That's not part of the answer. What does it mean for a function to be constant? Constant means not changing, so not going up or down. So where is the graph constant? So it's constant at x equals 0 and x equals 3. Okay. If we looked at this increasing interval here, at -2, is it going up or is it going down? Both, right? The linear portion is going down and the exponential portion is going up, so which is it? You need to include it in the correct function. Which domain covers -2? It tells us right here. -2 is part of the linear equation. So at -2, is it going up or down? Down. So the increasing interval here would look like this. Is it going up or down at 0? Neither. It's flat. All right. So when you finish that, hand it in. Turn to the other worksheet. Here you see 3 piecewise functions, and the first one looks really weird, but it's actually super simple. This says when x is less than or equal to 0, the function equals 3. When x is bigger than 0, the function equals 2. What would that graph look like? It's 2 straight lines. Well, I guess you'd call them rays. So here's my graph. Up here at 3, I have a line going that way, filled in circle. And at 2, I have a line going this way. So this says when x is less than or equal to 0, then f of x is the number 3. And when x is bigger than 0, f of x is the number 2. So for all negative numbers, you plug it in and you get out the number 3. For all positive numbers, you plug it in and you get out the number 2. So this is strange to you because there's no x in the function, but that doesn't matter. What about 0? Does it equal 2 or 3 at 0? 3, because 3 has the equal to. So the first question says f of 2. What is the value of the function when f is 2? 2. So f of 2 equals 2. Second one, what is the value of the function when x is -4? The value is 3. All right, let's skip to number 5. Now we're looking at function g. G of 7. Which function includes x equals 7? So our domains are x is less than or equal to 3. Is 7 less than or equal to 3? No. So it's not that one. Our other domain is x is bigger than 3. Does 7 satisfy that inequality? Is 7 bigger than 3? Yes? Uh-oh, I got lots of blank stares. Does that not make sense? Cheyenne, you all right? Okay. So 7 is bigger than 3, so this is the function I use. So now I plug the 7 in for x. 14 minus 1 is 13. And if you plug it into the wrong function, chances are you're going to get the wrong number. There is a really small chance that it actually will work, but virtually no chance at all. Okay? For the next one, g of 0. Which function includes x equals 0? The top one, x is smaller than or equal to 3. 0 is smaller than 3. So I take the 0 and I plug it into the top function and I get the number 5. Okay? All right. Now we need to graph. So I know that in this function, we're going to switch at 1. We'll do the first function until we hit 1, and then we'll do the second function from 1 on. Okay? So what do these graphs look like? Well, I'm going to graph 2x minus 3 here, and I'm going to graph 3x plus 1 there. And you can use your calculators to graph them if you want, but these are just linear equations, so hopefully we don't need it. So this one starts at negative 3, and it gains $2 every year, so it would look like this. The other one starts at 1, and it gains $3 a year, so it's going to be steeper than the first one. Okay? So how much of that top graph are we going to include? So of all of this line, how much of it do we actually use? So we use everything smaller than 1. So every x value from negative infinity up to 1. Well, what I need to know is, what is the point at which it stops? So here's my x equals 1. What is that point there? Well, it's really easy to find. Just plug this in. What is 2 times 1 minus 3? Negative 1. So these graphs aren't very good, but 1 comma negative 1. Is this going to be an open circle or a closed circle? Closed circle. And am I going to draw the line to the left or to the right? Well, it says every x value smaller than 1, so I'm going to do this portion of the graph right there. Yeah, as long as it's heading in the right direction, that's okay. All right. Now we're going to plug 1 into the other function. 3 times 1 is 3 plus 1 is 4. So 1 comma 4. Is this an open circle or a closed circle? Open circle. Am I going to go to the left or to the right? So I'm up here on the graph. Is it going to be the left side or is it going to be the right side? Right side. So it looks like that. And again, if the steepness of your lines isn't perfect, that's okay. As long as you have it going to the right and going up, that's good enough for me. Okay? Okay, we'll try another one. So I need to figure out what these two graphs look like. This one starts at negative 1 and it goes up $1 every year. The second one starts at positive 1 and it goes up $2 every year. Now I just need to pick the correct piece of each graph. So the domain says x is less than 2. So if I go over here to 2, I'm going to graph that portion. On the other one, I'm going to go over here to x equals 2, and I'm going to graph this portion. And I'm just going to put both of those pieces on the same graph. In order to figure out where they go, I plug 2. Let me move this. I plug 2 into both functions. So I put 2 there. So I get 2 comma, what happens when you plug in 2? 2 comma 1. Is this going to be an open circle or a closed circle? Open, because its x is less than 2. So I go to 2 comma 1, open circle, and then I just draw this line, which is going in that direction. Okay? Now for the second graph, I plug in 2. 2 times 2 is 4, plus 1 is 5. So the end point is 2 comma 5. Is it an open circle or a closed circle? Closed circle. So I go up here to 2 comma 5, closed circle, and then I draw this graph here, which is going to be in that direction. So you need to know where the graph is heading. You also need to know what the endpoints are and if the endpoints are closed or open. Okay, turn the page. Let's do the second problem. And again, if you don't know what the graphs look like, go ahead and graph them on your calculator, and then you can transfer them on. So the first graph has a y-intercept of 0, and it's gaining $1 every year, every 2 years. So it would look like that. The second graph starts at -2, and it's gaining $1 every year, so it looks like that. Okay. So now I need to figure out what the endpoints are. Well, I know that 4 is the x value that I changed from the first graph to the second graph. So I need to plug 4 into both of those. I plug 4 into the first one, and I get 2. So the point is 4, 2. Is this going to be open or closed? Open. So I go to 4, 2, and I draw an open circle. So that's right here on the graph. And then do I want to include the left side or the right side? Left side, because it says x is less than 4. So it's going to look like this. All right, for the second one, I plug in 2, and I get 4, 2. So this one actually has the endpoints in the same place. So I'm going to put a closed circle. If I have an open circle and a closed circle at the same point, is it open or closed? It's closed. So over here at 4, I'm going to draw this portion of the graph. So I just move that over here. And it looks like that. Yeah, it's steeper. Yeah, it's twice as steep as the other one. Good point. Okay. Look at the one on the bottom left. This will be the last one, and then you guys can work on your homework. So what does negative x squared look like? Wow. It's x squared only upside down. So it looks like this. So that's the first graph. What does negative x look like? It's a negative slope at a 45 degrees. Looks like this. And then the last graph is a positive x squared. So it looks like that. Again, you can graph those on your calculator to find them. So now I just need to figure out what the endpoints are. So I need to take -1 and plug it in here. What is the opposite of -1 squared? Well, -1 squared is 1, and the opposite of 1 is -1. So the point is -1, -1. Is that going to be open or closed? Open. So I go to -1, 1, and I draw an open circle. So over here, -1, 1, open circle, and I'm going to put this graph on there. So it's going to look like this. Okay. For the next one, I have to plug in 2 numbers. What is -1? So -1, 1. What is -1? If I plug in 1, the opposite of 1 is just 1, -1. So those are my endpoints. Are they open or closed? They're both closed. Cameron, you lost? Okay, so the formula is -x. So I want to plug in -1 and 1. If I put -1 in there, -1, what does it spit out? Positive 1, because it's the opposite of -1. If I put 1 in there, 1, what does it spit out? -1. So those are my endpoints, and they're both closed. So closed at -1, 1, and closed at 1, -1. So if I look over at my graph, I have a closed circle here and a closed circle here. The graph is everything in between. It's going to look like this. As for the last one, What do I get when I plug in 1? 1, open or close? Open. So I have an open circle here. So 1, 1, open circle. It's going to be this part of the graph. Looks like that. So if I had it all one color, kind of easier, well, kind of hard to see, but hopefully you get what I mean. Okay, so you need work on these tonight. I'll answer, if you have any questions, I'll answer those tomorrow.